I'd like to do one final plot, and I'm going to go ahead and turn this to a different view. So remember, I've got my first point is 1 millimeter away in the x-axis. You can see it right there. My second point is 1 millimeter in the y-axis. I'm going to make a third, in this case, instead of a point, I'm going to make a line. And I'm going to make this in the z-axis, which means I'm going out of plane. Notice how this is showing the xy plane. If I switch this to one of the other planes, I can now put a point along the z-axis, so it sees this orientation of the plane. So that's going to be helpful. But if you pay close attention to these steps, I'm going to reorient my view here. So now I can see z is up. So what I want to do is draw a line of a couple of millimeters in length. So I'm going to, this is a multi-step process. I'm going to choose draw line. It's asking me if I want to create a non-model object, and I'm going to say yes to that. It means that I get to keep the solutions. I'm not adding any real structure to this simulation, so nothing is going to change anyway. So non-model object means that I don't have to resolve. So if you look on the left-hand panel, you can see that the first location of this line where I'm entering the first vertex is going to be at 0.001 millimeter. I'm going to click once, and I'm going to zoom out. So I'm going to go from 1 millimeter to, let's say 10. So right now, this point is showing up as 0.010. And instead of a single click, I'm going to double click, which completes the operation of the line. And not super easy to see, but it's highlighted here as magenta going from 1 millimeter to 10 millimeters. So the reason I did that is because I want to show you another possibility for plotting. And when I go back to results this time, instead of choosing a data table, I'm going to choose a 2D plot. And my geometry, as you may have guessed, is going to be polyline 1. You can see it showed up here in the modeler tree. I'm still going to plot the magnitude of the electric field, but I'm doing it on a line instead of a point. This should look familiar to you. We have plotted this from the analytical result, and I'm not doing a direct comparison. I chose different values here, but certainly that behavior and that nature seems to look very similar. If I go and right-click in this plot and I choose Add Marker, I can find out what my exact value is at the very first point. Notice the distance 0 that's shown in the bottom is actually distance from the first vertex, which means it's 1 millimeter from the center of that charge. The marker indicates that value at that location, which I wanted to draw your attention to the fact that this is different, 9.126 times 10 to the 15th, compared to 8.978 times 10 to the 15th, and 8.85 times 10 to the 15th. All three of these values are exactly 1 millimeter away from the center, yet they give us different results. And that's a point of discussion I want to have in the next section on accuracy and how to possibly improve the result.